CNC router. Explanation: a computer-controlled cutting machine that translates designs into physical cuts on various materials using different types of router bits. Uses and applications: used in woodworking, metalworking, and composites for intricate cutting, shaping, and engraving. Major parts: spindle, router bits, gantry, table, and control system. CNC plasma cutter. Explanation: uses a high-velocity jet of ionized gas, plasma, to cut through electrically conductive materials. Uses and applications: ideal for cutting steel, aluminum, brass, and copper plates in industries like metal fabrication, automotive, and construction. Major parts: plasma torch, power supply, CNC control, and cutting table. CNC wire EDM, electrical discharge machining. Explanation: uses electrical discharges, sparks, to accurately cut through conductive materials. Uses and applications: used for intricate shapes, dies, and molds in tool and die making, aerospace, and medical industries. Major parts: wire electrode, dielectric fluid, CNC control, and workpiece. CNC sinker EDM, electrical discharge machining. Explanation: uses electrical discharges, sparks, between a tool, electrode, and a workpiece to remove material. Uses and applications: ideal for creating complex shapes and details in tool making, mold making, and aerospace components. Major parts: electrode, dielectric fluid, CNC control, and workpiece. CNC surface grinder. Explanation: uses a rotating abrasive wheel to remove material and create a smooth surface finish on metal and other materials. Uses and applications: essential in tool and die making, precision machining, and manufacturing of precision components. Major parts: grinding wheel, work table, wool guard, coolant system, and CNC control. CNC cylindrical grinder. Explanation: machines cylindrical workpieces to achieve precise dimensions and smooth surfaces. Uses and applications: used in automotive, aerospace, and tool manufacturing for grinding cylindrical parts like shafts and gears. Major parts: grinding wheel, workhead, tailstock, wool guard, coolant system, and CNC control. CNC tool and cutter grinder. Explanation: grinds and sharpens cutting tools with high precision. Uses and applications: essential in manufacturing and tool shops for regrinding and manufacturing cutting tools like end mills and drills. Major parts: grinding wheel, tool holder, spindle, coolant system, and CNC control. CNC gear hobbing machine. Explanation: cuts gear teeth using a hobbing tool to create gears with precise profiles. Uses and applications: found in gear manufacturing for producing gears used in automotive transmissions, industrial machinery, and robotics. Major parts: hobbing tool, workpiece, hob arbor, hob head, coolant system, and CNC control. CNC gear shaping machine. Explanation: uses a shaping tool to cut gear teeth into a workpiece. Uses and applications: used in gear manufacturing for producing internal and external gears with precise tooth profiles. Major parts: shaping tool, workpiece, tool slide, cutter head, coolant system, and CNC control. CNC gear grinding machine. Explanation: grinds gear teeth to achieve high precision and surface finish. Uses and applications: essential in gear manufacturing for finishing gears to exact specifications in automotive, aerospace, and heavy equipment industries. Major parts: grinding wheel, workpiece, wheel dresser, coolant system, and CNC control. CNC thread grinder. Explanation: grinds threads on workpieces to precise dimensions and profiles. Uses and applications: used in manufacturing precision threaded components like screws, nuts, and bolts for aerospace, automotive, and machinery industries. Major parts: grinding wheel, workpiece, dresser, coolant system, and CNC control. CNC broaching machine. Explanation: uses a broach tool to remove material and create precise internal or external shapes. Uses and applications found in manufacturing for producing keyways, splines, and other internal or external shapes in parts. Major parts: broach tool, workpiece, broach holder, coolant system, and CNC control. CNC jig borer. Explanation: drills, bores, and mills holes and pockets with high precision. Uses and applications essential in toolmaking and aerospace industries for machining precise holes and features in molds, dies, and components. Major parts: spindle, table, jig, coolant system, and CNC control. CNC horizontal boring machine. Explanation: bore holes in large workpieces with high precision using a horizontal spindle. Uses and applications used in heavy machinery and aerospace industries for machining large and complex parts with precise bores and profiles. Major parts: spindle, table, column, coolant system, and CNC control. CNC vertical boring machine. Explanation: bore holes in large workpieces with high precision using a vertical spindle. Uses and applications found in industries like automotive and aerospace for machining large cylindrical parts and creating precise bores and profiles. Major parts: spindle, table, column, coolant system, and CNC control. CNC planer. Explanation: uses a single point cutting tool to create flat surfaces on large workpieces. Uses and applications found in heavy machinery and toolmaking for machining large and flat surfaces on components and structures. Major parts: tool head, workpiece, table, column, coolant system, and CNC control. CNC shaper. Explanation: shapes metal or wood by moving a cutting tool in a linear motion. Uses and applications used in toolmaking and prototyping for shaping flat and contoured surfaces with high precision. Major parts: cutting tool, ram, table, column, coolant system, and CNC control. CNC slaughter. Explanation: cut slots and grooves in workpieces using a reciprocating cutting tool. Uses and applications found in manufacturing for creating slots, keyways, and grooves in components and parts with high precision. Major parts: cutting tool, ram, table, column, coolant system, and CNC control. CNC horizontal machining center. Explanation: performs milling, drilling, and tapping operations on large workpieces with a horizontal spindle. Uses and applications used in automotive, aerospace, and mold-making industries for machining complex parts with multiple operations. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC vertical machining center. Explanation: performs milling, drilling, and tapping operations on large workpieces with a vertical spindle. Uses and applications found in industries like aerospace and automotive for machining parts with complex geometries and precise features. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC bridge mill. Explanation: a large machining center with a bridge-like structure for heavy-duty and high-precision machining. Uses and applications used in manufacturing large components and molds requiring precise machining operations. Major parts: spindle, bridge structure, table, tool changer, coolant system, and CNC control. CNC gantry mill. Explanation: a machining center with a gantry structure for machining large workpieces with high precision. Uses and applications found in aerospace, automotive, and heavy machinery industries for machining large parts and structures. Major parts: spindle, gantry structure, table, tool changer, coolant system, and CNC control. CNC universal mill. Explanation: a versatile milling machine capable of performing various machining operations with multiple axes. Uses and applications used in toolmaking and general machining for milling complex parts and components with high precision. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC bed mill. Explanation: a milling machine with a fixed bed for stability and rigidity during machining operations. Uses and applications found in manufacturing and tool shops for machining heavy and large components with high precision. Major parts: spindle, bed, table, tool changer, coolant system, and CNC control. CNC knee mill. Explanation: a milling machine with a vertically adjustable knee for precise control during machining operations. Uses and applications: used in prototyping and general machining for milling components and parts with precise contours and profiles. Major parts: spindle, knee, table, tool changer, coolant system, and CNC control. CNC vertical mill. Explanation: a milling machine with a vertical spindle for machining workpieces vertically. Uses and applications: used in mold making, aerospace, and automotive industries for machining complex parts with high precision. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC precision mill. Explanation: a high-precision milling machine capable of achieving tight tolerances and fine finishes. Uses and applications: essential in aerospace, medical, and tool-making industries for machining components requiring high accuracy and surface quality. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC micro mill. Explanation: a small milling machine designed for micromachining and intricate part production. Uses and applications: used in electronics, medical device manufacturing, and precision engineering for micromilling and tiny component machining. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC mini mill. Explanation: a compact milling machine for small-scale machining and prototype production. Uses and applications: found in research labs, educational institutions, and small workshops for milling small parts and components. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC tabletop mill. Explanation: a small milling machine designed to fit on a tabletop or workbench for desktop machining. Uses and applications: ideal for hobbyists, makers, and small-scale production for milling small parts and components. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC bench mill. Explanation: a milling machine designed for benchtop use in small workshops and educational settings. Uses and applications: used by hobbyists, students, and small-scale manufacturers for milling small parts and prototypes. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC Swiss lathe. Explanation: a lathe machine designed for high-precision turning of small parts with intricate features. Uses and applications: found in medical device manufacturing, watchmaking, and aerospace industries for machining small and complex components. Major parts: spindle, turret, guide bushing, collet, coolant system, and CNC control. CNC multi-axis lathe. Explanation: a lathe machine with multiple axes for complex turning operations and machining. Uses and applications: used in aerospace, automotive, and medical industries for machining parts with intricate geometries and contours. Major parts: spindle, turret, tool holder, coolant system, and CNC control. CNC twin spindle lathe. Explanation: a lathe machine with two spindles for simultaneous machining of two workpieces. Uses and applications: found in automotive and aerospace industries for increasing productivity by machining multiple parts simultaneously. Major parts: spindles, turret, tool holder, coolant system, and CNC control. CNC live tool lathe. Explanation: a lathe machine equipped with live tooling attachments for milling, drilling, and tapping operations. Uses and applications: used in manufacturing complex parts with multiple operations like turning, milling, and drilling in a single setup. Major parts: spindle, turret, live tooling, coolant system, and CNC control. CNC bar feeder. Explanation: automatically feeds bars of material into a CNC lathe for continuous machining operations. Uses and applications found in high-volume production environments like automotive and medical industries for unmanned operation and increased productivity. Major parts: bar feeder mechanism, feed tube, guide channels, sensor system, and CNC control. CNC gantry router. Explanation: a CNC router with a gantry structure for machining large workpieces with high precision. Uses and applications: used in woodworking, composites, and metalworking for machining large parts, molds, and patterns. Major parts: gantry structure, router spindle, table, tool changer, coolant system, and CNC control. CNC foam cutter. Explanation: cuts foam materials using a hot wire or rotating cutter for creating shapes and profiles. Uses and applications found in packaging, signage, and insulation industries for cutting foam sheets and blocks with precision. Major parts: cutting head, wire or cutter, table, guide rails, coolant system, and CNC control. CNC leather cutter. Explanation: cuts leather materials using a knife or laser for precision cutting and engraving. Uses and applications: used in fashion, upholstery, and footwear industries for cutting leather patterns, designs, and components. Major parts: cutting tool or laser, table, guide rails, vacuum system, coolant system, and CNC control. CNC glass cutter. Explanation: cuts glass materials using a diamond or carbide wheel for precise cutting and shaping. Uses and applications found in glass fabrication, automotive, and architectural industries for cutting glass sheets and components. Major parts: cutting wheel, table, guide rails, coolant system, and CNC control. CNC fabric cutter. Explanation: cuts fabrics using a rotary blade or laser for precise cutting and pattern making. Uses and applications: used in garment manufacturing, upholstery, and textile industries for cutting fabrics with complex patterns and designs. Major parts: cutting tool or laser, table, guide rails, vacuum system, coolant system, and CNC control. CNC wood lathe. Explanation: a lathe machine designed specifically for turning wood to create turn profiles and shapes. Uses and applications found in woodworking and furniture industries for turning table legs, chair spindles, and decorative wood components. Major parts: spindle, tool rest, tailstock, bed, coolant system, and CNC control. CNC stone router. Explanation: a CNC router designed for cutting and shaping stone materials like granite and marble. Uses and applications found in monument making, architectural stone cutting, and countertop fabrication for shaping and engraving stone. Major parts: router spindle, cutting tools, bed, guide rails, coolant system, and CNC control. CNC wire bender. Explanation: bends wire materials into shapes and profiles using programmable bending heads. Uses and applications: used in manufacturing of wire forms, springs, and metal components requiring precise bending and shaping. Major parts: bending heads, tooling, guide rails, feed mechanism, coolant system, and CNC control. CNC rebar cutter. Explanation: cuts reinforcing bars, rebar, using blades or shearing mechanisms for construction applications. Uses and applications found in construction and concrete reinforcement industries for cutting rebar to specific lengths and shapes. Major parts: cutting blades or shears, feed mechanism, guide rails, coolant system, and CNC control. CNC rebar bender. Explanation: bends reinforcing bars, rebar, into shapes and configurations required in construction. Uses and applications: used in concrete construction for bending rebar into shapes like stirrups, hooks, and angles. Major parts: bending mechanisms, tooling, guide rails, feed mechanism, coolant system, and CNC control. CNC embroidery machine. Explanation: uses programmable needles to create intricate embroidered designs on fabrics. Uses and applications found in textile and garment industries for mass production of embroidered logos, designs, and patterns. Major parts: embroidery head, needles, hoop, thread feeders, touchscreen interface, and CNC control. CNC quilting machine. Explanation: quilts fabrics using automated stitching patterns and designs. Uses and applications: used in textile and home furnishings industries for quilting bedspreads, comforters, and decorative fabrics. Major parts: quilting head, needle bar, feed mechanism, frame, touchscreen interface, and CNC control. CNC knitting machine. Explanation: knits yarns into fabrics using automated needles and stitch patterns. Uses and applications: found in textile and apparel industries for knitting sweaters, socks, and textile fabrics with intricate patterns. Major parts: knitting head, needles, yarn feeders, fabric take-up rollers, touchscreen interface, and CNC control. CNC loom. Explanation: weaves yarns into fabrics using automated weaving patterns and techniques. Uses and applications: used in textile mills and weaving industries for producing woven fabrics like cotton, wool, and synthetic fibers. Major parts: loom frame, shuttle or shuttleless mechanism, warp beam, weft feeder, touchscreen interface, and CNC control. CNC laser marker. Explanation: marks materials using lasers for engraving, etching, and marking designs and codes. Uses and applications: found in manufacturing and packaging industries for marking logos, serial numbers, and barcodes on various materials. Major parts: laser source, marking head, focusing lens, work table, touchscreen interface, and CNC control. CNC laser engraver. Explanation: engraves designs and patterns on materials using lasers for decorative and functional purposes. Uses and applications: used in signage, awards, and customization industries for engraving logos, artwork, and text on materials like wood, acrylic, and metal. Major parts: laser source, engraving head, focusing lens, work table, touchscreen interface, and CNC control. CNC laser cutter. Explanation: cuts materials using lasers for precise and clean cuts in various thicknesses. Uses and applications: found in manufacturing, automotive, and aerospace industries for cutting metals, plastics, and composites with high accuracy. Major parts: laser source, cutting head, focusing lens, work table, touchscreen interface, and CNC control. CNC water jet cutter. Explanation: cuts materials using a high-pressure jet of water mixed with abrasive particles for fast and accurate cutting. Uses and applications: used in metal fabrication, stone cutting, and aerospace industries for cutting thick and hard materials with minimal heat-affected zones. Major parts: water jet nozzle, abrasive mixing chamber, high-pressure pump, work table, touchscreen interface, and CNC control. CNC ultrasonic cutter. Explanation: cuts materials using ultrasonic vibrations for precise and clean cuts without generating heat. Uses and applications: found in food processing, medical device manufacturing, and textiles for cutting delicate materials and components. Major parts: ultrasonic transducer, cutting tool, horn or blade, work table, touchscreen interface, and CNC control. CNC plasma cutter. Explanation: cuts materials using a high-velocity jet of ionized gas, plasma, for fast and precise cutting. Uses and applications: used in metal fabrication, automotive, and construction industries for cutting steel, aluminum, and other metals with high speed and accuracy. Major parts: plasma torch, power supply, cutting table, CNC control, and coolant system. CNC 3D printer. Explanation: builds three-dimensional objects layer by layer using additive manufacturing techniques. Uses and applications: found in prototyping, product development, and manufacturing industries for producing complex parts and components from various materials. Major parts: print head or extruder, build platform, filament or resin feeder, touchscreen interface, and CNC control. CNC robotics. Explanation: uses robotic arms and automated systems for performing various tasks like welding, assembly, and material handling. Uses and applications found in automotive assembly, electronics manufacturing, and logistics for improving efficiency and precision in production processes. Major parts: robotic arms, end effector or tooling, control panel, sensors, and CNC control. CNC wire bending machine. Explanation: bends wire materials into shapes and configurations using automated bending heads. Uses and applications: used in manufacturing of wire forms, springs, and metal components requiring precise bending and shaping. Major parts: bending heads, tooling, guide rails, feed mechanism, coolant system, and CNC control. CNC screw machine. Explanation: automates the production of screws, bolts, and other threaded components using multiple spindles and cutting tools. Uses and applications found in fastener manufacturing, automotive, and aerospace industries for producing high volumes of threaded parts with precision. Major parts: spindles, collets, cutting tools, turret, coolant system, and CNC control. CNC tube bender. Explanation: bends tubes and pipes into various shapes and configurations using automated bending heads. Uses and applications: used in automotive, aerospace, and plumbing industries for bending tubes and pipes with precise angles and dimensions. Major parts: bending heads, tooling, guide rails, mandrel, coolant system, and CNC control. CNC brake press. Explanation: bends sheet metal into desired shapes and angles using hydraulic or servoelectric press brakes. Uses and applications found in sheet metal fabrication, automotive, and aerospace industries for bending and forming sheet metal parts with high precision. Major parts: press brake, punch and die set, back gauge, hydraulic system, CNC control, and safety guards. CNC turret punch press. Explanation: punches holes and shapes in sheet metal using multiple punches and dies mounted on a turret. Uses and applications: used in sheet metal fabrication for punching holes, slots, and forms in sheet metal parts with high speed and accuracy. Major parts: turret, punch and die set, work table, CNC control, safety guards, and tool changer. CNC sheet metal cutter. Explanation: cuts sheet metal into precise shapes and contours using lasers, plasma, or water jet technology. Uses and applications found in sheet metal fabrication and manufacturing industries for cutting complex shapes and profiles in sheet metal parts. Major parts: cutting head, laser, plasma, or water jet, cutting table, CNC control, safety guards, and coolant system. CNC wire EDM, electrical discharge machining. Explanation: uses electrical discharges, sparks, to accurately cut through conductive materials. Uses and applications: used for intricate shapes, dies, and molds in tool and die making, aerospace, and medical industries. Major parts: wire electrode, dielectric fluid, CNC control, and workpiece. CNC sinker EDM, electrical discharge machining. Explanation: uses electrical discharges, sparks, between a tool, electrode, and a workpiece to remove material. Uses and applications: essential in manufacturing complex shapes and details in tool making, mold making, and aerospace components. Major parts: electrode, dielectric fluid, CNC control, and workpiece. CNC surface grinder. Explanation: uses an abrasive wheel to remove material and achieve high surface quality. Uses and applications: vital and precision machining and tool sharpening for achieving flat and smooth surfaces on metal and other materials. Major parts: grinding wheel, work table, wool guard, coolant system, and CNC control. CNC planer. Explanation: trims and smooths surfaces of large workpieces by removing excess material. Uses and applications found in woodworking and metal fabrication for machining large and flat surfaces on components and structures. Major parts: tool head, workpiece, table, column, coolant system, and CNC control. CNC shaper. Explanation: shapes metal or wood by moving a cutting tool in a linear motion. Uses and applications: used in toolmaking and prototyping for shaping flat and contoured surfaces with high precision. Major parts: cutting tool, ram, table, column, coolant system, and CNC control. CNC slaughter. Explanation: cut slots and grooves in workpieces using a reciprocating cutting tool. Uses and applications: found in manufacturing for creating slots, keyways, and grooves in components and parts with high precision. Major parts: cutting tool, ram, table, column, coolant system, and CNC control. CNC horizontal machining center. Explanation: performs milling, drilling, and tapping operations on large workpieces with a horizontal spindle. Uses and applications: used in automotive, aerospace, and mold-making industries for machining complex parts with multiple operations. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC vertical machining center. Explanation: performs milling, drilling, and tapping operations on large workpieces with a vertical spindle. Uses and applications: found in industries like aerospace and automotive for machining parts with complex geometries and precise features. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC gear hobbing machine. Explanation: cuts gear teeth using a hobbing tool to create gears with precise profiles. Uses and applications: found in gear manufacturing for producing gears used in automotive transmissions, industrial machinery, and robotics. Major parts: hobbing tool, workpiece, hob arbor, hob head, coolant system, and CNC control. CNC gear shaping machine. Explanation: uses a shaping tool to cut gear teeth into a workpiece. Uses and applications: used in gear manufacturing for producing internal and external gears with precise tooth profiles. Major parts: shaping tool, workpiece, tool slide, cutter head, coolant system, and CNC control. CNC gear grinding machine. Explanation: grinds gear teeth to achieve high precision and surface finish. Uses and applications: essential in gear manufacturing for finishing gears to exact specifications in automotive, aerospace, and heavy equipment industries. Major parts: grinding wheel, workpiece, wheel dresser, coolant system, and CNC control. CNC thread grinder. Explanation: grinds threads on workpieces to precise dimensions and profiles. Uses and applications: used in manufacturing precision threaded components like screws, nuts, and bolts for aerospace, automotive, and machinery industries. Major parts: grinding wheel, workpiece, wheel dresser, coolant system, and CNC control. CNC broaching machine. Explanation: uses a broach tool to cut internal or external shapes in workpieces. Uses and applications: found in automotive, aerospace, and tool-making industries for producing keyways, splines, and other internal or external profiles. Major parts: broach tool, workpiece, broach holder, coolant system, and CNC control. CNC honing machine. Explanation: uses abrasive stones to improve the geometry and surface finish of bores or holes. Uses and applications: found in automotive, aerospace, and hydraulic cylinder manufacturing for achieving precise bore dimensions and surface qualities. Major parts: honing stones, workpiece, spindle, coolant system, and CNC control. CNC surface roughness tester. Explanation: measures the surface roughness of machine components to ensure quality and consistency. Uses and applications: found in quality control and inspection departments of manufacturing industries for evaluating surface finishes of parts and components. Major parts: probe or sensor, measuring unit, display screen, and CNC control. CNC coordinate measuring machine, CMM. Explanation: measures the geometric dimensions of machine components using precision probes. Uses and applications: essential in quality assurance for verifying dimensional accuracy and tolerances of complex parts and assemblies. Major parts: probe or sensor, measuring table, coordinate system, software interface, and CNC control. CNC vision measuring system. Explanation: automatically measures dimensions, angles, and features of machine components using optical or vision-based technologies. Uses and applications: found in quality control and metrology for inspecting small and intricate parts with high accuracy and speed. Major parts: camera or optical system, measuring software, work table, lighting system, and CNC control. CNC hardness tester. Explanation: measures the hardness of materials using indentation or rebound techniques. Uses and applications: used in metallurgy, manufacturing, and quality control for assessing material hardness properties of machine components. Major parts: indenter or probe, measuring unit, display screen, and CNC control. CNC balancing machine. Explanation: balances rotating components like shafts, rotors, and turbines to reduce vibration and improve performance. Uses and applications: found in automotive, aerospace, and industrial machinery for ensuring smooth operation and longevity of rotating parts. Major parts: balancing unit, sensors, display screen, software interface, and CNC control. CNC inspection system. Explanation: automatically inspects machine components for dimensional accuracy, surface defects, and other quality parameters. Uses and applications: used in manufacturing and quality assurance for detecting defects and ensuring compliance with specifications. Major parts: sensors or probes, measuring tools, software interface, display screen, and CNC control. CNC robotic arm. Explanation: uses robotic arms and automated systems for performing various tasks like welding, assembly, and material handling. Uses and applications: found in automotive assembly, electronics manufacturing, and logistics for improving efficiency and precision in production processes. Major parts: robotic arms, end effector or tooling, control panel, sensors, and CNC control. CNC automated welding system. Explanation: uses robotic arms and automated welding equipment for precise and consistent welding operations. Uses and applications: found in automotive, aerospace, and metal fabrication for welding components with high accuracy and repeatability. Major parts: welding torch or gun, robotic arms, welding power supply, sensors, and CNC control. CNC automated assembly system. Explanation: uses robotic arms and automated systems for assembling components and products. Uses and applications: found in electronics, automotive, and consumer goods manufacturing for assembling products with speed and precision. Major parts: robotic arms, end effectors or grippers, assembly stations, sensors, and CNC control. CNC material handling system. Explanation: uses robotic arms and automated conveyors for handling and transporting materials within manufacturing facilities. Uses and applications: found in logistics, warehouses, and manufacturing for automating material movement and improving workflow efficiency. Major parts: robotic arms, conveyor systems, sensors, control panel, and CNC control. CNC inspection system. Explanation: automatically inspects machine components for dimensional accuracy, surface defects, and other quality parameters. Uses and applications: used in manufacturing and quality assurance for detecting defects and ensuring compliance with specifications. Major parts: sensors or probes, measuring tools, software interface, display screen, and CNC control. CNC engraving machine. Explanation: utilizes cutting tools to engrave designs or text on various materials. Uses and applications: used for engraving metal plates, jewelry, and industrial parts. Major parts: spindle, engraving bit, work table, CNC control, and cooling system. CNC polishing machine. Explanation: uses abrasive belts or wheels to polish surfaces to a high finish. Uses and applications: found in automotive and jewelry industries for polishing metal surfaces. Major parts: abrasive belt or wheel, work table, CNC control, and cooling system. CNC deep hole drilling machine. Explanation: specializes in drilling deep holes with high precision. Uses and applications: used in the aerospace and automotive industries for producing deep bores in engine components. Major parts: drilling head, guide bush, coolant system, work table, and CNC control. CNC vertical boring machine. Explanation: bores large holes in workpieces using a vertical spindle. Uses and applications: used in heavy machinery and automotive industries for boring engine blocks. Major parts: boring head, spindle, work table, coolant system, and CNC control. CNC horizontal boring machine. Explanation: bores large holes in workpieces using a horizontal spindle. Uses and applications: found in heavy machinery and construction equipment manufacturing for boring large components. Major parts: boring head, spindle, work table, coolant system, and CNC control. CNC tapping center. Explanation: specialized machine for high-speed tapping operations. Uses and applications: used in manufacturing for creating threaded holes in components. Major parts: tapping head, spindle, work table, coolant system, and CNC control. CNC multitasking machine. Explanation: capable of performing multiple machining operations such as milling, turning, and drilling. Uses and applications: used in automotive and aerospace industries for machining complex parts in a single setup. Major parts: spindle, tool changer, work table, coolant system, and CNC control. CNC horizontal turning center. Explanation: performs turning operations with a horizontal spindle. Uses and applications: found in manufacturing for producing cylindrical parts. Major parts: spindle, turret, chuck, work table, and CNC control. CNC vertical turning center. Explanation: performs turning operations with a vertical spindle. Uses and applications: used for machining large, heavy workpieces in aerospace and automotive industries. Major parts: spindle, turret, chuck, work table, and CNC control. CNC vertical grinding machine. Explanation: uses a vertical spindle for precision grinding operations. Uses and applications: found in tool and die making for grinding flat and contoured surfaces. Major parts: grinding wheel, spindle, work table, coolant system, and CNC control. CNC horizontal grinding machine. Explanation: uses a horizontal spindle for precision grinding operations. Uses and applications: used in manufacturing for achieving high surface quality on cylindrical and flat surfaces. Major parts: grinding wheel, spindle, work table, coolant system, and CNC control. CNC cylindrical grinder. Explanation: precisely grinds the outer surfaces of cylindrical workpieces. Uses and applications: found in automotive and tool manufacturing for grinding shafts and cylinders. Major parts: grinding wheel, work table, spindle, coolant system, and CNC control. CNC internal grinder. Explanation: grinds the internal surfaces of cylindrical workpieces. Uses and applications: used in manufacturing for precision grinding of bores and holes. Major parts: grinding wheel, spindle, work table, coolant system, and CNC control. CNC camshaft grinder. Explanation: grinds camshaft lobes with high precision for engine performance. Uses and applications: used in automotive and racing industries for manufacturing camshafts to exact specifications. Major parts: grinding wheel, camshaft holder, CNC control, coolant system, and wheel dresser. CNC cylindrical grinder. Explanation: grinds cylindrical surfaces of workpieces for high precision and finish. Uses and applications: essential in manufacturing for finishing shafts, rods, and cylindrical parts. Major parts: grinding wheel, workpiece holder, CNC control, coolant system, and wheel dresser. CNC ID/OD grinder. Explanation: grinds internal and external diameters of workpieces. Uses and applications: used in precision manufacturing for producing parts with tight tolerances on internal and external surfaces. Major parts: grinding wheel, workpiece holder, CNC control, coolant system, and wheel dresser. CNC creep feed grinder. Explanation: performs deep grinding operations with high material removal rates. Uses and applications: used in aerospace and turbine industries for grinding hard materials like superalloys. Major parts: grinding wheel, work table, CNC control, coolant system, and wheel dresser. CNC centerless grinder. Explanation: grinds the outer surface of cylindrical workpieces without using centers. Uses and applications: found in manufacturing for high-volume production of precision shafts, pins, and rollers. Major parts: grinding wheel, regulating wheel, work rest, CNC control, and coolant system. CNC gear hob sharpening machine. Explanation: sharpens the cutting edges of gear hobbing tools. Uses and applications: essential in gear manufacturing for maintaining the sharpness and accuracy of hobbing tools. Major parts: grinding wheel, hob holder, CNC control, coolant system, and wheel dresser. CNC thread rolling machine. Explanation: forms threads on workpieces by rolling between dies. Uses and applications: used in fastener manufacturing for producing high-strength threads on bolts, screws, and studs. Major parts: rolling dies, workpiece holder, CNC control, hydraulic system, and coolant system. CNC helical broaching machine. Explanation: cuts helical splines and grooves in workpieces. Uses and applications: found in automotive and aerospace industries for producing parts with helical profiles. Major parts: broach tool, workpiece holder, CNC control, hydraulic system, and coolant system. CNC riveting machine. Explanation: joins components using rivets for strong and durable assemblies. Uses and applications: used in aerospace, automotive, and construction industries for assembling panels and structures. Major parts: rivet gun, workpiece holder, CNC control, hydraulic system, and riveting dies. CNC swaging machine. Explanation: forms metal tubes and rods by reducing their diameter through deformation. Uses and applications: found in manufacturing of cables, hoses, and metal rods for creating swaged ends or connections. Major parts: swaging dies, workpiece holder, CNC control, hydraulic system, and cooling system. CNC shearing machine. Explanation: cuts sheet metal and plates using a shearing action for precise edges. Uses and applications: used in sheet metal fabrication for cutting sheets into desired sizes and shapes. Major parts: shear blades, work table, CNC control, hydraulic system, and back gauge. CNC punching machine. Explanation: punches holes and shapes in sheet metal using a punching tool. Uses and applications: found in sheet metal fabrication for creating holes, slots, and shapes in metal parts. Major parts: punch tool, die, work table, CNC control, and hydraulic system. CNC pipe cutting machine. Explanation: cuts pipes and tubes to precise lengths using various cutting technologies. Uses and applications: used in plumbing, construction, and manufacturing for cutting pipes and tubes with clean edges. Major parts: cutting tool, saw, laser, or plasma, work table, CNC control, and clamping system. CNC pipe bending machine. Explanation: bends pipes and tubes into specific shapes and angles using automated bending heads. Uses and applications: found in automotive, aerospace, and plumbing industries for creating bent pipes and tubes. Major parts: bending heads, tooling, guide rails, CNC control, and hydraulic system. CNC pipe threading machine. Explanation: cuts threads on the ends of pipes for creating threaded connections. Uses and applications: used in plumbing, oil and gas, and construction industries for threading pipes. Major parts: threading dies, workpiece holder, CNC control, coolant system, and hydraulic system. CNC pipe welding machine. Explanation: welds pipes together using automated welding processes for strong joints. Uses and applications: found in oil and gas, construction, and pipeline industries for welding pipes. Major parts: welding torch, workpiece holder, CNC control, power supply, and cooling system. CNC tube laser cutting machine. Explanation: cuts tubes and profiles using laser technology for precise and intricate cuts. Uses and applications: used in automotive, aerospace, and construction for cutting complex shapes in tubes. Major parts: laser source, cutting head, work table, CNC control, and clamping system. CNC tube punching machine. Explanation: punches holes and shapes in tubes using a punching tool. Uses and applications: found in automotive, furniture, and construction industries for creating holes in tubular components. Major parts: punch tool, die, work table, CNC control, and hydraulic system. CNC tube end forming machine. Explanation: forms the ends of tubes into specific shapes for connections and fittings. Uses and applications: used in automotive, aerospace, and plumbing for creating flared, reduced, or expanded tube ends. Major parts: forming dies, workpiece holder, CNC control, hydraulic system, and cooling system. CNC tube chamfering machine. Explanation: chamfers the ends of tubes for smooth and precise edges. Uses and applications: found in automotive, aerospace, and manufacturing for preparing tube ends for welding or assembly. Major parts: chamfering tool, workpiece holder, CNC control, coolant system, and clamping system. CNC tube notching machine. Explanation: notches tubes for creating joints and connections. Uses and applications: used in automotive, furniture, and construction for creating notched ends in tubes. Major parts: notching tool, workpiece holder, CNC control, hydraulic system, and clamping system. CNC tube polishing machine. Explanation: polishes the surface of tubes for a smooth and shiny finish. Uses and applications: found in manufacturing, automotive, and furniture for finishing tubes to a high-quality surface. Major parts: polishing wheel, workpiece holder, CNC control, coolant system, and clamping system. CNC tube deburring machine. Explanation: removes burrs and sharp edges from the ends of cut tubes. Uses and applications: used in automotive, aerospace, and manufacturing for deburring tube ends after cutting. Major parts: deburring tool, workpiece holder, CNC control, coolant system, and clamping system. CNC tube marking machine. Explanation: marks tubes with identification numbers, logos, or other information. Uses and applications: found in manufacturing, automotive, and construction for marking tubes with important information. Major parts: marking tool, laser, inkjet, or engraver, workpiece holder, CNC control, and clamping system. CNC hydraulic press. Explanation: uses hydraulic pressure to shape and form materials. Uses and applications: found in automotive, aerospace, and manufacturing for forming metal components such as car panels and structural parts. Major parts: hydraulic cylinders, press frame, control panel, die sets, and CNC control. CNC tube cutting machine. Explanation: cuts tubes and pipes to specified lengths and angles. Uses and applications: used in plumbing, automotive, and construction for cutting metal and plastic pipes and tubes accurately. Major parts: cutting head, tube feeder, control panel, cutting blade, and CNC control. CNC punching machine. Explanation: uses punches and dies to cut holes and shapes in sheet metal. Uses and applications: found in sheet metal fabrication for creating holes, slots, and shapes in metal sheets. Major parts: punches, dies, turret, work table, and CNC control. CNC beam drilling machine. Explanation: drills holes in large structural beams and profiles. Uses and applications: used in construction and steel fabrication for drilling precise holes in beams and other structural elements. Major parts: drilling heads, beam support, control panel, coolant system, and CNC control. CNC beam cutting machine. Explanation: cuts large structural beams to specified lengths and shapes. Uses and applications: found in construction and steel fabrication for cutting beams, channels, and other structural elements. Major parts: cutting head, beam support, control panel, cutting blade, and CNC control. CNC pipe bending machine. Explanation: bends pipes to precise angles and shapes. Uses and applications: used in plumbing, automotive, and construction for bending pipes and tubes accurately. Major parts: bending heads, pipe feeder, control panel, mandrel, and CNC control. CNC milling machine. Explanation: uses rotary cutters to remove material from a workpiece. Uses and applications: found in manufacturing, aerospace, and automotive industries for creating complex parts and components. Major parts: spindle, table, tool changer, coolant system, and CNC control. CNC grinding machine. Explanation: uses an abrasive wheel to remove material and achieve high surface quality. Uses and applications: vital and precision machining and tool sharpening for achieving flat and smooth surfaces on metal and other materials. Major parts: grinding wheel, work table, wool guard, coolant system, and CNC control. CNC tapping machine. Explanation: creates internal threads and holes using taps. Uses and applications: used in manufacturing for creating threaded holes in parts and components. Major parts: tapping head, work table, coolant system, and CNC control. CNC tube notching machine. Explanation: cuts notches into tubes for precise fitting and assembly. Uses and applications: found in plumbing, automotive, and construction for preparing tubes for welding and assembly. Major parts: notching head, tube feeder, control panel, cutting blade, and CNC control. CNC EDM hole drilling machine. Explanation: drill small holes using electrical discharges. Uses and applications: used in aerospace, toolmaking, and medical device manufacturing for drilling precise small holes. Major parts: EDM head, dielectric fluid, control panel, work table, and CNC control. CNC wire straightening and cutting machine. Explanation: straightens and cuts wire to specified lengths. Uses and applications: found in manufacturing and construction for preparing wire for further processing or use. Major parts: straightening rollers, cutting head, wire feeder, control panel, and CNC control. CNC tube end forming machine. Explanation: forms the ends of tubes into specified shapes for fitting and assembly. Uses and applications: used in plumbing, automotive, and HVAC for preparing tube ends for connections. Major parts: forming heads, tube feeder, control panel, mandrel, and CNC control. CNC bar bending machine. Explanation: bends metal bars to specified angles and shapes. Uses and applications: found in construction and manufacturing for bending rebar and other metal bars. Major parts: bending heads, bar feeder, control panel, mandrel, and CNC control. CNC roll forming machine. Explanation: forms metal sheets into desired profiles using rolling dies. Uses and applications: used in construction and manufacturing for producing metal profiles like gutters and roofing panels. Major parts: rolling dies, sheet feeder, control panel, and CNC control. CNC coil slitting machine. Explanation: slits metal coils into narrower strips. Uses and applications: found in metal fabrication for preparing coils for further processing or use. Major parts: slitting knives, coil feeder, control panel, and CNC control. CNC spiral duct machine. Explanation forms metal sheets into spiral ducts for HVAC systems. Uses and applications used in HVAC manufacturing for producing ducts used in heating, ventilation, and air conditioning systems. Major parts forming heads, sheet feeder, control panel, and CNC control.